In R, there are various ways to fit classification trees to data, so either to continuous data or in the case of the example that we're going to look at in this video, where there's a categorical response variable which specifies a number of different classes in which the data can fall. So we could either make use of the tree function in the tree package, or we can make use of the rpart function for recursive partitioning that's in the rpart package within R. So first thing we need to do is to make the package available in our session with the require function, and what we're going to be looking at is a dataset retrieved from the UCI machine learning repository, which is on E. coli, and what we're going to be looking at is the classes, and here we've got the class distribution based on the localization site, where we've got 8 different categories, and we're going to be using a small number of predictor variables to do the classification. So the first thing that we need to do is to load in the data sets. We'll just have a quick look in the R session here. So the last column is the class in which the particular case belongs, and then the MCV to ALN2 are the variables that have been recorded on each of the observations in the data set. So what we will look at, well, first of all, we're going to set the seed for this particular session. So we just picked out one at random here. So this is made use of during the rpart function when it's doing the recursive partitioning. So as with a lot of data sets in R, we make use of a formula to specify the model that's being fitted. So class is our categorical variable, and these are some continuous measurements that are going to be used for the partitioning. And the function itself is rpart for recursive partitioning, and we save it as an object here, which we can then do some various things with. So one of the first questions that we want to look at is how large a tree do we need to do a decent classification of our data. So we use the plot CP function, which plots our metric for determining how good our variable is against CP, and that corresponds to the size of the tree. So we take this point here below the dashed line, and we're looking to create a tree of size 6 for our particular purposes here. So we can then use the print CP function, and we just see we get some output here, and for a tree of size 6 we're looking for a CP of less than 0.02. So we then go and look at pruning our tree. So the function prune does that pruning, and we specify a CP of 0.02 in this case here. So we prune the tree, save it to an object, and then we can use the plot function and the text function to create a visualization of our classification tree. So here we see we've got the various splits based on different variables, and then where we end up with in our classification when we reach a particular point. And then at each of those points we've got the number of cases that are classified in each of the groups. So we can see situations where classifications seems to have got a lot of things in the right place, and other where there's a little bit more confusion amongst the groupings of particular cases.